Welcome to this demonstration of the earthquake early warning system for British Columbia. My name is Kent Johansen, and I have, together with the University of British Columbia, under the lead of Dr. Carlos Ventura, developed and installed the Tetra 2 sensors in the coastal areas of British Columbia. The network is now installed and we are able to show live data from it. This visualization display of the earthquake early warning system is like having a vantage point up in a very high tree watching British Columbia from Victoria in the south to Chilliwack in the east and all the way up to Powell River, where we have two schools with each two sensors, and Gibsons, where we have two schools with two sensors, and downtown and the lower mainland, which is very dense. We'll turn it on and we'll watch the little green graphs that are showing how much noise is at each site. This is literally as it happens. We have latencies down to maybe 2 to 10 milliseconds on a bad day, and we're watching this as the noise is happening out there. It might be school children, it might be cars driving by, and since it is an urban area, we have to discriminate false signals of machinery and whatever else we can encounter. Right now it's very quiet, and even if these graphs became about 1/3 of the screen tall, it would not trigger an earthquake warning in the about 150 schools that we presently have alarms in. And I can with confidence say that as I'm speaking, there is no earthquakes going through the lower mainland. The sensors that are lying still, little blocks next to each other, are the ones that are planned for the Ministry of Education. Always we have installed them in pairs of 2 for the redundancy. I have now rewound time to the 7th of January 2015 at 18:03 p.m. when an earthquake of magnitude 4.8 hit Tofino. It was just strong enough to swing a chandelier about 5 centimeters back and forth, and it was not felt in Powell River, the closest station, or anywhere in the lower mainland. We will see at 17 seconds past, the P wave now hits Powell River, and about 10 seconds later the S wave will hit. That is what would have created the damage if the earthquake was strong enough. So Powell River, 10 seconds warning before the shaking really starts. Now it goes to Gibsons, and we'll see the graph getting slightly taller there, and then it goes downtown. But the main shaking does not hit downtown until about 55 seconds past, which is almost 40 seconds later. Then finally it propagates out to Maple Ridge and to Abbotsford and to Chilliwack. Here's the main shaking at 55 seconds. And everything kind of dies out, and finally, as the last shaking, Delta is discovering that something is happening and starts sloshing a little bit back and forth. This is very swampy ground, and we could expect some very heavy liquefaction out there, and it responds quite differently than the rest of the town. Already that we can see, but there was not one report that this earthquake was felt even in any of the areas that we see on this map. So the earthquake early warning system is certainly sensitive enough to detect events that would create actual damage. It should be stressed that the event we just witnessed was a very small earthquake. Even at the epicenter in Tofino, it did not do any damage, but merely managed to get the chandeliers to swing a bit back and forth. In Powell River, where it was not felt, there was a maximum acceleration of 1.1 milli-G during the S wave and only about 0.3 milli-G during the P wave. This is about 1/10 of what we require to trigger the alarms in the schools. It did, however, demonstrate that even with a local sensor and a local alarm, Powell River would have gotten 10 seconds of warning before the shaking started. Downtown would have had almost 40 seconds of warning, which would be enough to get out of a building or a gym. And this is what the earthquake early warning system aims to do. Thank you.